What is up, party people? Today we are looking at LA-7. Um, just a friendly reminder that I may be. I created some examples for this video, and they are representative of your assignment, but they are not exactly what your assignment is asking for. So just make sure here that you follow the questions in LA-7 and don't necessarily take what I am doing in this video word for word. But like I said, this should be representative of your assignment, and you should be able to follow closely along and get this assignment done. So first things first, we're going to install and load our packages. Should just be able to copy and paste this from a previous assignment. I set up my working directory, which is something you need to do only if you're in our studio, but if you're still using POSIT Cloud, you don't need to worry about that. Next thing, I am going to create a data set called COVID using the function read.csv to read the COVID.csv data set that you should download off of Canvas. Once I run that, it should show up in my environment. And now that it's in my environment, we can get started. So everything that we just did should just be review. If you have questions, reach out, look at some previous videos, or maybe even your previous assignments. So question 2 is I changed it up a little bit. So make sure that you don't use the example that I provide here, but use the follow the assignment question. So we'll go ahead and start. It is asking us to create a new variable and then to run a frequency distribution of that variable. The variable I have decided to create is called language. This is the question's asking for something else here, but just make sure that you fill in what is required. The variable is equal to English if the country is in Canada or the United States, and the variable is equal to Spanish is if the country is in Mexico or Spain, and then I also put Korean if the country is South Korea. So first things first, I'll just walk us through it. I'm creating a new data set called LG, assigned to my pre-existing data set COVID. I'm running a pipe operator here, which is the percentage sign, little arrow, and then percentage sign. I click enter. Whenever I'm creating a new variable, I'm going to use the mutate function. So mutate to create a new variable. This new variable is called language in this case, but for you it will be called something else. I'm going to assign language to various cases and using the case when function. And then in the case that the country is in, using the percentage sign IN percentage sign, in case that it's in Canada or United States, I will use the combine function C to say Canada, and then make sure those are in quotations. United States. Make sure here that first off you're spelling it right. Your tense, it's capitalized, and then you have a comma here. Once that's done, you can close the parenthesis. You're going to use a little squiggly line here, and then you're going to assign that to English. In my case, for you, it should be a. I think you guys are looking at consonants, so I'm going to then put a comma here because the function is not yet over. I'm going to do this whole thing again. Country, percentage sign in, percentage sign, combine function, and then in quotations, Mexico, and comma, quotation, Spain, and then close that parenthesis, little squiggly line, and then this one is assigned to Spanish. One more comma, and then in the case that the country is in combine South Korea, close quotation, close parenthesis, little squiggly line. I'm going to call that one Korean. Make sure you close the quotations and then close the two functions. The one is mutates, and then the next one is case when. So everything here is in between those functions. And now when I run that, I should get a new data set called LG. You know it works because it has one new variable. And then I could just run a frequency distribution of that, which should give me this nice little table, which shows me the frequency, 24 English, 14 Korean, and 20 Spanish. So that should help you there. Remember, start with your data set. The new one I created is LG. I used a pipe operator here, and then I used the frequency function to look at language. Yeah, so that is how you should conduct number 2. So we'll move on to number 3. So it's asking us to conduct a statistical test to determine whether or not, and this is the example, this is the assignment question, to determine whether or not the total number of contacts differs by region. So you need to answer the questions below and include your answers in the R file. So I went ahead and created another data set that creates a region according to countries and assigns them to different continents. That is what your assignment is asking for. So in order to finish number 3, we need to have an understanding of what a categorical and a continuous variable is. So quick little definition is a categorical variable is a variable that can take on a limited and usually fixed number of possible values. So this is often maybe a color, or maybe a political affiliation, or maybe a grade level in terms of like K through 12, like I am in the 11th grade or I am a freshman in college. Those are all categorical variables. On the other hand, a continuous variable is a variable that takes on an infinite number of possible values within a given range. So think something like temperature, or maybe speed. These are examples of continuous variables. In this case, it is asking us to figure out which variables are involved in this statistical test. So which is the independent and which is the dependent. Remember, the dependent variable is the variable that is being changed. So if we look it up here, we're determining whether the total number of contacts differs by region. So we can, region and total number of contacts are the two variables. I'll let you decide which is the dependent and independent. And then you will also determine whether or not these variables are continuous or categorical. And then by looking at the assignment flowchart, I think I have it pulled up here. Hopefully y'all can see this. So here's the LA-7. At the bottom here is this flowchart. You can follow these to figure out which tests you need to do. For this, you'll need these two. So, and then once you do that, you can scroll down lower and look at how to run these tests in your assignment. All right, back to R. We went ahead and created our new data set called regions. We decided that we are going to run an ANOVA test looking at total contacts in region. So when we run that, there's a couple different ways we can do it. We can create a new character value that is assigned essentially to the results of this, or we could just have it just display immediately in our console. That tends to be how I like to do it, but I'll show you guys real quick what it looks like if I do that and then use the summary function. This is kind of nice because it kind of makes it a little bit bigger, but if we look at our original one, which is probably what you all are going to look at, it should be pretty easy to understand. So we'll go ahead and get started there. So when looking at the results here, I'll just go ahead and copy and paste this so we can zoom in on it. So this is, I just copy and paste this from my console. So when looking at this, it is an ANOVA table. We want to see the region. Here is our p-value, and here's our test statistic. When looking at our results here, it's helpful to have a basic understanding of what we're looking at here. So our test statistic, I found this nice website. I'll share it with y'all. It's scribbler.com, but it just gives us a good example of how to look at the data. So down here, we see that the F value, which right here in the R script, is the test statistic, and it is the mean square of each independent variable divided by the mean square of the residual variables. So the larger the test statistic, the more likely it is that there's a variation caused by the independent variable. And then down here we have our p-value, which as we can see, it is less than 0.05. And this will show us how likely it is that the test statistic calculated from the test would have occurred if the null hypothesis, meaning that there is no relationship between the two variables, is true. So anyways, so our p-value here is 0.0071, which is less than 0.05, meaning that there is a strong correlation between total contacts and region, and our test statistic is 7.505. Cool. So question 5 now is asking us to compare how mask wearing differs between the first and second year of the COVID outbreak. So looking at our COVID data, we don't have anything that determines the years. All we have is days since outbreak. So that should raise a little flag that we're going to need to likely create a new variable using pre-existing data. So A is, you should answer this however you think. Then you are going to identify the dependent variable, and then as well as the independent variable. You're going to be creating a new independent variable using the mutate function again. So that should help you when looking at determining which of these is the dependent variable. So we can assume that mask wearing is the dependent variable, and then our new one is year since. I'll walk us through this real quick. So I created a new data set called year using pre-existing data set called regions that I created from my Nova test. I used the pipe operator, which has the percentage sign, arrow, percentage sign. I create a new variable called year since using the mutate function. And this is assigned to the case when the day since outbreak in 1 is less than or equal to 365 days. I assign that to 1, and then comma, and then for my second case, day since outbreak is greater than 365, and I assign that to 2. Make sure everything is spelled correctly. The cases are how it's spelled here. And then you are closing your function. You are using a little squiggly line here. And yeah, so that should help you in mask wearing. So if we look at our data, we see the masks outside is what we probably want to look at when looking for mask wearing. So looking at this data, we see there is a large variety of numbers, likely on a scale. We can see that this exists in a range, and there is likely an infinite number of possibilities here. So we probably would think of mask wearing as a continuous variable. But then when we are looking at years since and something like days, we can assume that these are categorical variables because there is only a limited amount of days in a year, and how many years since COVID. That does not exist on a infinite there's not an infinite number of possibilities in the range between days and years there. So looking at our chart on the assignment that I expressed earlier, I decided to use a t-test. I went ahead and filled in the information there, mask outside and years since. And then it's asking us to report the test statistic and probability. I need to run my function real quick. So here it shows us our test statistic and it shows us our p-value. We see that the p-value is less than 0.05. So that means we're pretty confident that there is a correlation between mask outside and years since. So, but we don't necessarily know what that difference is yet. So now we can filter out. F here is asking us to calculate the means and standard deviation of the dependent variable, which is years since, to determine whether or not the first or second year more people wore masks when they went outside. So I went ahead and started with my new data set, which I called year. I used my pipe operator. I filtered out for when the year since is equal to 1, another pipe operator, and then I described using the describe function the variable of mask outside. Did that same thing for year 2. And when I ran that, it gives me a nice little table that shows me not only the mean but also the standard deviation. So that is what the question is asking for here. And then looking at that, we can see that there is a difference in the means. One is 82. I'll just go ahead and copy and paste these real quick. So year 1, year 2, we can see that in year one, the average was 82.5 masks outside, and the standard deviation is pretty high here. But then for year two, we see there's 91.27 average mass outside, and the standard deviation is 6.63. So by looking at the mean, associating that the p-value is less than 0.5 or 0.05, sorry, we can assume that there is a significant correlation between year since and masks outside. All right, hopefully that helped. I'll share this link to the website. This was very helpful. Walks us through the results as well as how to get it. Feel free to ask me any questions you may have. Yeah, thanks y'all. We'll see you next week. Bye.